Today on Fun with Math, we will be talking about symmetry. An object is symmetrical when one half is a mirror image of the other half. It may be divided by one or more lines of symmetry. Before we begin, we should know about a few definitions. This is a triangle. These here are the triangle's vertexes. These here are the triangle's sides. Now, a symmetrical line cuts a shape in half so that the two sides can be mirrored images. With an odd number side shape, you would draw your line from vertex to side. So from here, I'm going to draw a vertical symmetrical line that will cut the triangle in half, allowing this side and this side to be mirror images of each other. This is a square. It has 4 vertexes and 4 sides. With an even number of sides, you can draw the line from side to side or from vertex to vertex. So to begin, I will start with the vertical line of symmetry we drew for the triangle, cutting the square in half this way, or we can draw a line horizontally. Cutting the square from top to bottom. But wait, there's more. You can also cut it from vertex to vertex. You can also go from this vertex to this vertex. A circle doesn't have a single vertex or a single side. So, how do we find a line of symmetry? Through the center. Every line that crosses through the center can create a line of symmetry. That is why a circle is known to have radial symmetry. So we can start with the vertical line of symmetry. A horizontal line of symmetry. A diagonal line of symmetry. Maybe a diagonal line of symmetry from this side. We can come in from this way. We can come in from this way. Or this way. Or this way. Quite honestly, when it comes to a circle, every point that crosses through the center creates a line of symmetry, making it completely mirrored image on either side.
Previously, we stated that with an even number of sides, we can draw lines of symmetry from side to side or from vertex to vertex, but that isn't the case with the regular shapes. Regular shapes do not have equal angles or equal sides. So for this shape, you can draw lines of symmetry from vertex to vertex, and then from this one. But you can't draw them from side to side. And for the rectangle, you can draw them from side to side. But not from vertex to vertex. It should be noted that if we draw a line from side to side on the diamond, or from vertex to vertex on the rectangle, the two halves would be congruent, which means that they are equal sides, but they would not be symmetrical because they are not mirror images. Congruent does not always mean they are symmetrical.
We previously showed you that a square has 4 lines of symmetry and a triangle has 3 lines of symmetry. Regular shapes have the same amount of lines of symmetry equal to the amount of sides they have. For instance, the pentagon has 5 sides, so it's safe to assume that it has 5 lines of symmetry.
1, 2, 3, 4, 5.
The octagon has 8 sides, therefore it should have 8 lines of symmetry.
One, two, three, four, 5, 6, 7, 8. This heart has one line of symmetry right down the center. This heart has none.
Symmetry can be found all around us, including the alphabet. This capital E and capital D have horizontal symmetry, while this capital V and capital W have vertical symmetry. The lowercase e and d have no symmetry, but the lowercase v and lowercase w have lines of symmetry that are equal to their counterparts.
Some letters have 2 lines of symmetry, such as this X and this O. They both have vertical lines of symmetry and they both have horizontal lines of symmetry. Well, I wonder what we have in our pockets that could be symmetrical. How'd you even fit that in there?
Post-it notes.
I need this.
So let's find some lines of symmetry. Would you look at that?
Symmetry is all about balance. You can find symmetry in art, in photography, and in architecture. Symmetry is important because balance is important. Balance in mathematics and balance in life.